However much work you put into cleaning things, it never seems to take long for them to get dirty again. And keeping things clean can be hard if your left hand doesn't know what your right foot's doing. Why is it important to get rid of dirt? What harm can dirt do if you don't keep it under control? Why do you think toilets need special attention? What dangers could there be if they're not properly cleaned? And why should you always wash your hands after going to the toilet? What extra cleaning problems might pets give you? How can you get rid of dirt? The simplest way is called abrasion. The brushes scrape the dirt off the pavement and into a collecting box. You can use abrasion to scrape the dirt off an elephant. And once the dirt is loose, this mahout uses water to wash it away. When do you use a mixture of water and abrasion? Water on its own may not remove all the dirt. Cats have rough tongues. How does that help them to get clean? How else do animals keep themselves clean? What about baboons? Vacuum cleaners use brushes to loosen the dirt and suction to lift it into the collection bag. Suction is also useful for clearing storm drains. They sometimes get blocked by leaves and other rubbish. This has to be sucked away to get the water flowing again. But sometimes abrasion and suction aren't enough, and you need to use chemical action. If your kettle gets all furred up, the best way to get it clean is to use a chemical called a descaler. How do you think this works? And what other things do you clean with chemicals? Chemicals can be used for protection too. Ducks take oil from a special gland and smear it on their feathers. This makes them waterproof and helps the ducks to float. Putting wax on a car protects the paint and makes it easier to wash off the dirt next time. You use both abrasion and chemicals when you clean your teeth. Can teeth be protected by chemicals? Some toothpaste contains fluoride, and fluoride is supposed to protect your teeth. What attacks your teeth is acid, and acid attacks eggshell too, so if fluoride protects your teeth, it ought to protect eggshell. This special mouthwash has lots of fluoride, so it ought to be better at protecting eggshell. Why do you think he's using 2 eggs? And why is he treating only half of each egg with fluoride? How would you test to see if the protection works? First, wash the chemicals off the eggs. Then put them both in acid. This egg has been treated with toothpaste. And this one with mouthwash. Both eggs fizz a bit, but the right-hand end of this egg was protected by the mouthwash and is not being attacked by the acid. What fair test would you do to try and find out whether fluoride toothpaste works?
Don't forget to keep brushing your gums.
And what else matters if you want to avoid tooth decay? When you're trying to get things clean, you have to decide what sort of cleaner to use. Do you have to use a different cleaner for every job, or can you use one cleaner for everything? There are an awful lot of cleaners in the shops. How do you decide which ones to buy? And how would you sort them out to find out how they work? These scientists are looking at the action of different cleaners, like abrasives. Abrasives clean like little brushes by scraping off the dirt. How would you decide which ones work best? And how would you make sure they didn't scratch the surfaces they were meant to be cleaning? One important job for cleaners is getting rid of stains. These scientists are trying out 4 different cleaners. First, hot water on its own. Next, washing powder. Third, washing up liquid. And fourth, bleach. Is this a fair test? And which will give the best results? Bleach has removed everything except the paint. But washing up liquid isn't much use. Can you always use bleach on stained clothes, or would it be safer to use washing powder, which is quite good at getting rid of stains? Hot water alone is no use, so how do these other cleaners work? Washing powder contains detergent. Shake a cleaner up with water, and if the cleaner contains detergent, then what you'll get is froth. To test for bleach in a cleaner, use cobalt chloride paper. Bleach turns cobalt chloride paper black. To test for abrasive grit in a cleaner, you need a nitty-gritty test. First, mix it thoroughly with a solvent. Second, filter the mixture. If there's grit in the cleaner, you'll get grit in the filter paper. What else might you find in cleaners? Some cleaners contain acid, and an easy way to test for acid is with indicator paper. Many cleaners have warnings on the back. What useful information could you get from these warning labels?
Flash liquid.
When you know what's in all the cleaners,
Window lane.
then you can sort them out into groups.
Hand cleaner.
How would you do it? How would you decide what groups to make? And which cleaners would you put in each group?
A Windowing Plus.
If you had to wash your own clothes, which powder would you choose? Which brand is best? Do you believe all the ads on the telly?
I know your problem. It's wash day and you're confused by wash day doubt. You don't know which way to turn to get your wash clean, the way you want it. Really confident clean. But now there's Super Clean, the powder for the 21st century. At only twice the price of ordinary washing powders, Super Clean is our gift to the special few who know what clean means. Super Clean is the total laundry support system in a box. Woolens, synthetics, colours, whites, hot water, cold water, hard or soft. No matter what your problem, Super Clean's your answer. Plus, total fabric saturation, a revolutionary concept in wash day care. You'll know what clean really means when you wash with Super Clean. Super Clean not only makes your wash cleaner, whiter and brighter, but also reduces the need for tiresome ironing. That's right. You'll certainly do a lot less ironing with Super Clean. Super Clean, science's gift to bring joy and happiness every time you wash your clothes. Someday, all washing powders will be made this way.
What fair test could you do to compare different washing powders? These scientists are using special test strips with identical stains on them. And they're trying to find out whether new Super Clean is better than another well-known brand of washing powder, but they don't know which one is A and which one is B. Do you think there'll be any difference? Do you care? Can you tell which strip was washed in new Super Clean? When scientists want to study cleaning, they go to great lengths to make their tests fair. This is international standard dirt. If you want to compare vacuum cleaners all over the world, then the only way to keep the tests fair is to make sure they're all done with exactly the same sort of dirt. To test vacuum cleaning on a real carpet with ordinary household dirt, a scientist might use a special vacuum cleaner that collects all the dirt in a box. Suppose you wanted to compare ordinary vacuum cleaners. How would you set up a fair test to find out which was best? What sorts of problems are there about getting things clean in the world outside? What sort of dirt might you have to deal with? What types of cleaners can you use to lift it? And once the dirt has been lifted, how can you get rid of it? If you have to clean a building, there are various ways of removing the dirt. You may be able to knock it off with a high-pressure water jet. Or you may find it's better to use a chemical cleaner to lift the dirt and then wash it away with the water. What sort of cleaner do you think might be effective? Ships sometimes spill oil into the sea. This can make a terrible mess of the coastline. How would you try and clean it up before it gets to the shore? How do you think straw might help? And can you think of any chemical cleaner that might get the oil out of the water? If it settles on the beach in thick, sticky chunks, then clearing it up is a mechanical problem. But it can be much worse when it's floating about in the water because of the damage it does to wildlife. How would you try to clean birds that are all glued up with sticky oil? If you wash them with detergent, you may wash off all their own oil as well, and then they'll sink when they get back in the water. Oil pollution is a serious problem, but some coastlines are polluted by stuff that's much more frightening. This place uses radioactive material. Although the beach looks safe enough, these scientists are studying the level of radioactivity in the sand. Radioactive dirt is dangerous. There isn't enough of it to see, but the Geiger counter can detect minute amounts. How do you think it could be cleared off the beach? If the radioactive dirt gets onto the beach, do you think it could also blow through the air and get into the houses inland? This scientist is collecting the vacuum cleaner bag to check. Can you think why? Suppose there was radioactive dust in the house. How would you try to get rid of it? Round the edges of your teeth, there's stuff called plaque. It looks like dirty bits of old food, but in fact this stuff is alive. Plaque is a kind of microbeast. Look under the microscope and you can see the microbeasts wiggling about. Plaque feeds on sugar and makes acid. It's the acid that rots your teeth. You can't get rid of plaque, but what you can do is cut down the sugar it feeds on. So, why is it important to brush your teeth? How could you find out what's the most effective method of brushing? And what shouldn't you eat if you want to avoid tooth decay?
Don't forget, Quantum can be seen this afternoon at 1:10 with